In this video, we're going to take a look at the practice quiz for Focus Quiz 7. Number 1 says graph the function and identify the key features of the graph. So the first thing to do is factor out anything you can. So the numerator is already factored as much as possible. So we're going to just leave x minus 1 like it is. The denominator has x squared minus x minus 6. So we need to try to figure out what will multiply to be negative 6 and add up to negative 1, the middle number. So 1 times negative 6 and negative 1 times 6 are possibilities, but they don't add up to negative 1. We have negative 2 times 3, but that would add up to positive 1. So we need 2 times negative 3, and they would add up to negative 1. So positive 2 plus negative 3. And so then we could factor x plus 2, x minus 3 at the bottom. And then we can start putting together the rest of the problem. The x-intercepts and y-intercepts we're just going to find in Desmos in a minute. The vertical asymptotes come from the denominator. So that means where the denominator would equal 0 is where your vertical asymptotes are. So if I set each one of these equal to 0, I'm going to use a different color just to help it stand out on the graph in a minute. So x plus 2 equals 0, x minus 3 equals 0 would give me x equals negative 2 and x equals 3 for my vertical asymptotes. So that means over here on my graph, I can graph an imaginary vertical line, a vertical line, at those numbers. So negative 2 and 3 are imaginary lines that my graph will never touch. But I get them from the denominator. Alright, the horizontal asymptote comes from the degree. So you need to compare the degree in the top. So the top has a degree of 1 because your highest exponent is a 1. It might be easier to look at the original problem to look at degree because you easily can see the 1, or like not the 1, but the 2 at the bottom is easy to see. And the 1 at the top is understood to be there. So we have a higher degree in the denominator, which means the horizontal asymptote is automatically at y equals 0. So let's go ahead and just graph a horizontal asymptote, so an imaginary horizontal line. Then it asks about holes. So holes occur when you have a common factor in the numerator and the denominator. So in this case, we did not have any that crossed out, so we have no holes. And so now I'm just going to type in my original problem into Desmos and take a look at the graph, and that way I'll pick out the x and y intercepts. So I'm going to put parentheses x minus 1 divided by, and then in parentheses I'm going to put x squared minus x minus 6. So I can easily see where to draw the branches of the graph. And usually they've already kind of labeled the x, the y-intercept, and the x-intercept. So the y-intercept looks like 0.167. So just leave it like that. No need to really change it. The x-intercept is at 1, 0. So it's nice and clean. 1, 0. And then your branches of your graph, we can tell, are like down. And then in the middle it goes like looks like a cubic function. And then it's in the like first quadrant looking area of the graph, I like to call it. So we're just going to sketch these little branches on our paper. So if we know the x-intercept is at 1, we could easily plot that point to help make it look a little bit nicer. As long as you don't cross over the asymptotes, you're doing all right. So that looks like an effective graph that matches what we have on our Desmos, and we've picked everything out. Let's look at number 2. Number 2 says simplify the following rational expression and state any restrictions on the variable and show all of your steps. So we need to factor everything first. That is always the first step. So this is a difference of squares. So I'm going to take the square root of x squared and the square root of 9, and I get x plus 3, x minus 3. I need to multiply to get negative 3 and add to get 2 for my denominator. So 3 times negative 1 or negative 3 times 1 are the only two options. And 3 times negative 1 would help to add up to positive 2. So I just need to write that directly into my factors. X plus 3, x minus 1. And so we're just simplifying. So if we want to pick out our restrictions before we cross anything out, you look at the denominator and you see like where would this binomial equal 0 for what value of x. So it's what plus 3 equals 0, which would be negative 3. So I'm going to write it down here at the bottom of the screen where there's an x is not equal to. So x cannot equal negative 3. In the second binomial, what minus 1 would equal 0? So that would be positive 1. So we say x cannot equal negative 3 or positive 1 because those would make the denominator equal to 0. And then we can simplify. So we can cross out the two that they have in common and bring over what's left. So showing your work is important and simplifying it is important. It's good to rewrite your answer so it's nice and clear and maybe even circle it for me. And then at the bottom, put the restrictions in that blank that says x is not equal to. So number 3 is a multiplying problem. It's just a little bit bigger than the simplifying one. You just have 2 fractions instead of 1. So I'm going to start by factoring everything out. So my first numerator, I have to figure out what will multiply to be 4 and add up to 4. So that's x plus 2, x plus 2. At the bottom, I have a difference of 2 squares. So x squared minus 49 would factor into x minus 7, x plus 7. In my next numerator, it's just a greatest common factor that I could take out, which is x. And I have x times x minus 7. At the bottom, we can't really do anything with x plus 2, so just bring that down. So you always want to make sure that if you multiplied your factors back together, you would get what you started with. So always keep that in mind when you are factoring. So in my denominator, I have 3 places where it could possibly equal 0. So I would say x cannot equal 7, or negative 7, or negative 2. And just write those at the bottom. Those are the values that would make those denominators, those binomials in the denominator equal to 0. And none of them can equal 0. That is not okay. So then we can cancel out common factors that we have in the numerator and the denominator. And write what's left over. So we end up with x times x plus 2 in the numerator over x plus 7 in the denominator. And that's it for number 3. Number 4 is divide the following rational expressions, state any restrictions on the variable, and show all of my steps. So remember, we're going to keep it, change it, flip it, or multiply the first fraction by the reciprocal of the second one. So this turns it into multiplying. So this is where you need to keep it, change it, flip it. Meaning keep the first fraction the way it is, but factor it out. So we're going to factor a difference of squares in our numerator. So that would give me y plus 2, y minus 2. The denominator, I need to multiply to get 36 and add to get negative 12. That'll be y minus 6 and another y minus 6. Then change the sign to multiplying. And then flip the second fraction. So I'm going to factor the numerator, but I'm going to write it in the denominator in this next step. It just saves you from having to write it twice. So I could take out a greatest common factor of 5, and I would have y minus 2 left over. And then if I factor the denominator, I got to multiply to get negative 6 and add to get negative 5. So that would be y minus 6y plus 1. And again, write the denominator in the numerator, and you've taken care of the flip it part. So now we can write down our restrictions. You look at the denominator and see what would make these equal to 0. So anywhere your variable would make the denominator equal to 0 are restricted values. So x cannot equal 6 or 2. Now let's cancel out common factors. So we have y minus 6 in the top and the bottom, and y minus 2 in the top and the bottom. And it's always just 1 for 1. You can't cancel out more than a pair of them. So that other one could not go away of the y minus 6. We're left with y plus 2 times y plus 1 over 5 times y minus 6. And that is it for number 4. And the last one says, add the following rational expression, state any restrictions on the variable, show all of your steps. So the first thing to do is factor the denominator so we could figure out what the least common denominator would be. So in this case, 2 times x minus 3 would work because it's a denominator that I could easily turn both of them into, because the first denominator already is that denominator. No work needed. But the second denominator, I could just multiply by 2, and that would make it look like the first one. So with a minimal amount of effort, I can make them the same. So 2 times 8 would give me 16, and then you want to keep the denominator that you've made the same. You don't have to distribute the 2, so you could just leave it that way. And then combine the numerator. So 5x and 16 are not like terms, but we at least need to write them all together in one fraction. And we need to just say that x cannot equal 3 because that would have made the denominator equal to 0. And I believe that's it for our